I'm just gonna have us introduce ourselves like real quick, and then I can get into more about what I do. But whoever wants to go next.
My name is Michael Murray, and I've been in the analytics and data warehouse for really since the last century, and I'm here primarily to talk about data engineering and some of the challenges that I was doing today. So it'll be fun. Some questions for you, back and forth. Question that I had to ask some people quite a bit. And it'll be a fun.
Chris Lewis, I also work at mainly this competition.
So the idea of this event is to have three different people who do very different types of data work and kind of give us some information about three paths we could go, all having to do with data. So I'm in the data science space. For the most part, data science is advanced statistical modeling and predictive analytics. So what that means in layman's terms, so if there's a business process or say sales, or I've done a model predicting seed count, we will create and train models on old data, historical data, and try to predict things before they happen. And in a lot of cases, we'll reallocate resources based on those. The other things that I've done are just basic optimization. So a lot of simulation. Seeing how much data we should collect and how much we need to collect to get the information that we need. So those are the main spaces that I've been in. So the main things that you need to do this type of work, so it's basic statistics is where you should start. I advocate that. That's why I teach basic statistics before I moved on. I teach a class here before I moved on to stuff that is more advanced, because I feel like you have to have a base. And then also machine learning is a base that most data scientists use and know. Also, base is getting a lot more in AWS, which is a cloud service. So you can do analytics and a lot of other things, data warehousing. So we'll have a lot to talk about with that. But that basically everything runs through the internet on Amazon servers. And big data. So at Whole Foods, we have transaction level data. You can imagine how many people purchase something every single day at all of the stores in the nation. So when you are trying to analyze that data, you often need tools like SQL, which run very quickly and analyze a lot of data at once, or parallel processing is usually your smart thing to do. So those can be put on the cloud. Those are the main things the skills that most data scientists have. So a typical day for me is mostly in front of the computer, at some meetings as well, working with stakeholders and getting information, working with my colleagues. But most of my day is coding in R. Python is another big tool that data scientists tend to use, and as well as SQL. But at Whole Foods, they normally have you working on one major project at a time, but I've been in jobs where I was working on 6 projects at a time, and it was just, I was more in the ad hoc space. But I do several long-term projects, usually work on them for a month or two. And what I really like about it is it's kind of like a puzzle. There's always a problem to fix, and there's different ways to do everything, and you have to figure out the best way to do it, and then debug code at the same time. And I find that really fun. So the reason I started this course, so I have a statistics and an R programming course at the library here, is to kind of give everyone a sample of what data science is like without them having to go pay 15 grand for a boot camp. To at least get an idea of what it's like before you pay the money to get into that. So, all right, I'll hand it off to whoever wants to go.
So, as I said, I'm gonna start with a question. And the question to the audience, you guys can just kind of think about when I talk, just to set the frame, is Puerto Rico a state or a country? Right. So, I am currently dealing with a real business process challenge. We need to roll up transactional level data, specifically invoice data, and we'll exclude currency conversion. I need to say we need to roll up invoice data, both monetary unit and quantity, along a hierarchy to a global level. So we've got EMEA, we've got Americas, and then I believe there is of Asia. Then we've got the unknown or other regions. So taking a look at the data pipelines are actually fairly interesting. I normally deal in what I would call an Oracle ecosystem. So when I talk about an Oracle ecosystem, Oracle most people think of as a database or business suite, which is their enterprise resource planning. So it's basically what allows you to manufacture, it allows you to invoice, it allows you to receive payments. So what you would think of as R2R, report to report, to receives, order to cash, and then the last one is either source or procure to pay. So specifically, I'm taking a look at invoices that need to get rolled up. Well, okay, there's an invoice transaction. You have a bill to location, you have a ship to location, and there could be additional identifiers that exist on the transactional record. However, those transactional records, because of the way that the application stores the data, are related in about 12 entities to get you back to something that would either represent a country ISO, which is a 2-character code for it, and then a state code, which is lucky to be a state. And for our purposes, we have what's called the ragged hierarchy. So within the United States, we need to go down to the state level, okay, because of the transacted within the United States. In other countries, they don't so much care. Argentina, fine, problem. So we think about, what is Puerto Rico? Keep asking yourself this question. So PR, 2-digit code. Interestingly enough, both the state and a country ISO, 2-digit codes. So we start doing what I like to call data archaeology, and this is all done with SQL, so structured query language, into the back end of ES database. So if that weren't complicated enough, there is another entity, I say entity, table. It is the territories table, which will relate back to a territory ID. Yeah, so you see where this is going, right? And interestingly enough, in the territory table, the two-digit country ISO for United Arab Emirates is not only in the United Arab Emirates, it's also in India, which makes it in EMEA and in Asia. So this is all coming back to the salient point here is that before Kelsey could do any of her modeling, she needs good data. And so we're dealing with, data scientists. If you look at statistics, about 60% of the time the data scientists are doing work, they're trying to figure out the data. So I spend my time, not only, so we've talked about EBS and the challenges with it. Well, there's another tool that Oracle has, which is a hierarchy management tool. So it's like, all right, we're going to create a hierarchy outside of the ERP just to be able to maintain the hierarchy so that we can theoretically push and pull data. So at the same time, as we're doing the data archaeology within the transactional system, I'm also interrogating, we'll say, like running code to pull the information out. Well, other system, what do you think, Puerto Rico? Do you think it's a state, or do you think it's a country? So now I'm asking the different systems, right? What do we think? And I decided, for the intents, since I have essentially complete control of the hierarchy maintenance system right now, I decided that I was going to play around with it and start pushing modifications in, and then running data pipelines to pull that information out, and to see when we run a load, when we run the pipeline, does the data aggregate up appropriately or not? Do we have orphan transactions? Are we rolling to the United States? Are we rolling to Mexico? Are we rolling to Latin America? Are we rolling to North America? It all goes into Americas, right? And then the fun part is that we're trying to tie back to a separate third system, and this third system is an existing legacy warehouse that has a whole separate code base. So it's essentially, now I ask the other system, well, other system, what do you think Puerto Rico is? Do you think it's a state, or do you think it's a country? So the answer, as it turns out, Puerto Rico is both a state and a country, according to the systems of record. Doesn't matter what I think, it matters what the system thinks. So then we're gonna get into a process to say, okay, data stewards, data owners, do we have a decision, and is that decision going to be made and then propagated as to the state or non-statehood of Puerto Rico? And do we propagate that across all these legacy transactions that the business has already been done? So that is, I guess we need to have another person on a panel up here who's a data governance person. Because I can say that okay, here's what the systems think, which doesn't really, it is the reality of the systems, but it may not be the reality that the business wants to move forward, and it may not allow Kelsey to generate models and train models even that will be effective or accurate.
Dunk in, dunk out.
Yeah. So that's just a small kind of, okay, what's Puerto Rico?
Isn't it really dependent on some kind of question you have an answer? Because, I mean, there may be reasons that you do it, or you could have a separate role if it's just for.
And interestingly enough, in the hierarchy maintenance tool, there actually is right now a primary and an alternate hierarchy. And the hierarchies are generally, okay, what do the financial organizations within, say, departments within the structure, how do they want to see the data versus how do the salespeople want to see the data? It's a different thing. And a Yeah, another third roll-up would be kind of the manufacturing is a supply chain people want to see the data. But they're generally lower on the total for what I'm doing, because they're not a profit center, they're a cost center. And that's generally, they get served last.
For one thing. Many years ago, I used early version of ERP and was responsible for, I think we had 6 different structures within video, there was product, there was responsibility, there were operational organizations, just different ways to look at it, the same sort of thing. But also,
It is a very common challenge that we don't really think about.
even if you look at ISO and UN, you've got different ways of splitting it work.
And it changes.
Yeah.
I can go to you, and then the idea here is we'll give a little spiel, and then you'll ask us any questions. So, I will move on to Chris.
Yeah, so, currently I play in it's called analytics, where businesses present a problem, we solve it. It could be that data is currently in a space that isn't taken up by data engineering standpoint, but they still need that information. Figure out how to do it very quick, very dirty, end up putting it in a Tableau dashboard. So one of the main tools that I use my day-to-day business is called Alteryx. So Alteryx, I took this right from their website, is a self-service data analytic movement platform that can cover, prep, analyze all of your data, play and share analytics at scale for deeper insights faster than you ever. Alteryx actually has 4 tools. The one that I play in day in and day out is called Timer. Actually work process the data. The other 3 are server/gallery, which we have full use. That just allows you to take your workflows, schedule them, or give an ability to share them out with them. The third one is called text, which is a metadata that allows you to see, allows you to go out and say, I need to figure out sales is, and connect with somebody. Fourth tool is called Promote. It actually allows you to share models out into different types. It creates an API that those last 2 that they are. This is a nice little kind of visual of what makes Alteryx different. The repeatability of processing, build something every time you not as common when you're working in Excel or some of the other tools that many analysts use. It's kind of hard to replicate the same thing. Take those manual tasks out. It is both code-free and code-friendly. So some users will use it and not have to write a single But for those who know code, it's powerful. You can actually embed Python code, R code, batch file command. I'm not going to go through all of these, but definitely something to look at. What I do want to focus on tonight is where I've been playing a lot of the analytic app. So once you build a workflow, you can actually build a user interface on top of that workflow. It would allow a user to say, I only need this piece of information. So what it might look like is something like this. A user can then input anything from a numerical value to just a checkbox, to drop down, to they even have tree files, so you can drill at a categorical hierarchy level view. And it really just allows you to empower end users to go grab ad hoc requests. You're not answering 50 of those in a day. Where most of them are live. The one I've been working on lately. So we're actually trying to standardize the way we do sales. And what this app actually allows you to do, if you look up here, yeah, that first little checkbox would allow a user to fill into the item hierarchies if they have it open, and choose what level they want. The second one would be along our score hierarchy. So they can decide what they want. I don't have to decide. And then they get to choose their range of dates of when they want to look at it. On the second tab, they get to decide at what level of granularity they want to look at when it comes to sales. And then in the query itself, it gives them the option of what columns they want to look at. If they get it by score, maybe it's just by region, different items. And then the last piece, it actually gives them the option to save anywhere. The nice thing with it's actually put onto Alteryx Gallery, and Alteryx Gallery can't save to desktops or My Documents or anything like that. It has to be a shared location, so it keeps the data within the whole. Alteryx also has the ability to read out to write back to Teradata, so if they're comfortable, they can actually write it out to a table, they can use it. So this is what Alteryx Designer looks like. I just built this really quick. It has two little pieces of information just to start date and end date. And it automatically does this. I didn't have to write any code for it to bring this calendar up. I just had to drag a tool on the canvas and it did that for me. Super simplistic. I can choose first, button, finish. I get two pieces of information. Ask for. I also get a different. That's just a very simplistic. These are the types of things that take the coding out of building.
So when I worked at Bayer, one of the huge struggles that we had was not everybody knew how to use SQL, but we had to pull data from our databases. They have since moved to AWS, but still SQL is going to be required in a lot of cases. So they were trying to build something themselves to do that, and I went back and was like, oh, this really cool tool, Alteryx, they would already do it all for you. I doubt they took my advice. But, it was, I'm somewhat new to SQL, so it's, when I was learning how to do it, you can either write the actual SQL code, or there are checkboxes and things that you can do that it will write for you. So, it's a really awesome tool. I mostly use R, and I'm learning Python right now, so, that is more like you have to learn, it's similar to learning the language. It's somewhat difficult at the beginning, gets easier, but I think Alteryx takes that out of the equation. So, like we were saying, most of my team uses R because everyone knows it. But other people in the business who don't know it can do very complex. Just real quick, I'll give a high-level example of something that I had done in the past. I can't give too many details, but so when I used to work at Bayer Cropscience, and they have a pipeline, a testing pipeline, and they have to provide seed for all the parts of their testing pipeline, or they can't test something, and they can't put it through the pipeline. So in order to try to get that seed, it goes through, as you can imagine, the stages of planting, transplanting, pollination, and there is a lot more to it. But I built a model that could predict which products of ours, based on a lot of different factors, would predict whether it would succeed or fail. There was a minimum number of seeds that you could have. And if it didn't meet that minimum standard, it had to start over with the entire process of our testing pipeline. So I tried many machine learning models. There's this really cool tool. It's AutoML, or auto machine learning, is coming up quite a bit. But Data Robot is something that we used for this particular project. It's mostly enterprises use it because it's extremely expensive. But basically, you can drop in a CSV, press a button, and it'll run very machine learning models on your data in 5 to 10 minutes. So what we used that for was to kind of get an idea of what worked and what didn't. And say a machine learning model one did really well, then we would actually code it to know exactly what was going on. But so we all did that, and I also looked at more standard statistical linear models, and it actually, the linear model was better in this case, so we went with that. But we then created that model, and the results, we basically predicted what would do well, what wouldn't do well, and the things that were supposed to do well, we took resources and put them where they weren't supposed to do well, and it decreased failure by quite a bit. So that's an example of a data science model. So you've kind of seen 3 different types of work and examples of what 3 different types of data that careers can do. So the idea was just to kind of give you a little bit of information and then open up to questions. And if you ask a question, you are welcome to come up and choose. I have our studio stickers and a coffee mug up here. So please fire away.
Question. I'm looking at different types of tools and wondering what the best way is to try some of them out. You download some of these operations.
Yes.
Can you try it in any fashion? You have to buy it first.
Go ahead.
Yeah, so Alteryx on their website has a 14-day trial. Yes, it doesn't really help a ton there. One nice thing is if you manage to get access to like a .edu, you can get a super cheap one. But even then, I would say on their community site, so community.alteryx.com, they have a bunch of videos and stuff that get you exposure to the tool without actually using it. So
I learned by hand.
And on my side of things, most of the data science tools that you use are open source, which means that they're free. So actually Mac already, if you have a Mac, Python's already on there. And if not, if you have a PC, it's simple to download. R is the same way. So those are the main tools in SQL. So you have to have a database to run SQL on. But also, for instance, if you wanted to get exposure to cloud tools like AWS is Amazon's version, Microsoft has a version, IBM has a version. They actually have free tiers online, so you get a certain number of database queries and certain number of space on the cloud, and you can run code for a certain amount of time every month, and you have a cap and it's different for all these different cloud sources, but you can go on and try that out and see what it does and get a lot of exposure to that without having to pay anything. You have to monitor it to make sure you're not going over the free tier, but there's ways to do that. So those are the main tools that I would say I use, but I mean, one of the parts of me trying to teach the class is to kind of get people to do those, because it's very hard to pick it up on your own. I had exposure to SAS before my Bayer Cropscience job, and it's very, very, very different than R. So I worked really long days trying to figure out and debug and figure out how to use R. And if somebody, in a lot of cases, would have sat down with me for 10, 15 minutes, it would have solved hours and hours and hours of debugging. So that's what I'm trying to provide for everyone. So hopefully that's helpful, but I recommend not to bring it forward, but I'll show my website at the end and I can show you how to get there and if you want to. Yeah.
Yeah, so we're living in interesting times in the workplace, because there is a large push to go to cloud, and a lot of the software, in fact, almost all the software that I've discussed with you is cloud-based. However, it's the same software that you can download and install from Oracle sites. Interestingly enough, Oracle has the licensing agreement. As long as you don't stick something into production, you can use whatever software they have and spin it up. Now, that's assuming that you are familiar with enterprise class software and know what a virtual machine is and can get into a command prompt and spin up a Linux instance. There's some significant barriers to entry when you're talking about the enterprise class applications that I deal with. Now, on the same, by the same token, there are significant numbers of open source relational database management systems out there. Oracle, in fact, acquired MySQL, still open source. You can still go that up, and there's a lot of information. How to do what I do is primarily hack SQL well as much as I can. You can download that stuff, spin it up very quickly. It's not resource intensive, and there are a number of tools that develop environments like allow you to connect up to the database applications and start doing things.
I was curious, sorry, I got this one. In learning some of these tools, a lot of the times the barriers I've seen is finding like exercises, data sets that, because obviously I can't just type in to make some data. You don't know if there's libraries of example data sets that you can use as your own, self-training exercises?
Let me repeat the question. So, the question was, where do we find data to try and figure out how to use these tools? Is there a place or a repository to get that?
Yeah, so, I'll start off, within Alteryx, community.alteryx.com, they do weekly challenges. Data's already baked in the challenges. But then outside of Alteryx, you have Kaggle as a and then also a lot of the government websites also have access to all the data. Last year or 2 years ago, I'm working on actually curious hurricane impact. We actually went out to the NOAA website and downloaded a bunch of data off of there.
And so our all a lot of the tutorials in R.
Chris mentioned Kaggle, so that's a big one for data science in general. I mean, when I was applying for my job at Whole Foods, you're seeing on like job descriptions, whether you've been in Kaggle and whether you have a GitHub, for instance. So especially the larger companies are actually looking, Kaggle is a competition website basically, where you're given a task and then you have to go and do it. Speed is involved, like that you get points for speed and for accuracy. And Data Robot, which I was talking about earlier, when they started as a company, they actually found top people on Kaggle and then poached them and made them employees in their company. So, and when you look at job descriptions, you see that. Are you a Kaggle user? So I think that that's one way that is really good to help you get into the data science, because it's really good practice and you're competing against really incredible people who know what they're doing, and then you can learn from them. Just to go off of like the government data as well, I used to work in public health. There is so much health data online, it just is mind-boggling. So one thing that I do for my course, I do kind of have a lot of it is public health related. I'm trying to pull from different areas as well. I do a lot with opioid data. There's a ton of that. So I'm right now, just as a side hobby project, there is a data set that exists online that's publicly available that has every publicly funded substance abuse treatment in the entire country in one file. And most people don't even know that that exists. It's because I just will Google it and dig and dig and dig, and you can find these things. I actually did my graduate degree capstone with that data. So another one that is oceanic data is available, and it's good. Also baseball data, if you're interested more in that. So there's something in everywhere, and then Kaggle also has a repository. There's also I might know the name of this, maybe, because I can't remember the name, I can Google it. But there's a university that puts machine learning practice data up on there. I can Google it now. That could possibly be it. Okay, UCI, yes, that's right. So UCI, they tend to be pretty outdated, the data sets, but they're specifically machine learning related.
There's a website called data.world.
Yeah.
And it's another place where there's all kinds of people post their data sets.
Their goal is to have all open. And they're building proprietary data now. Eventually,
We're talking about data.world.
Yeah, I think even last piece, a lot of companies are also starting to put data out through APIs. There's a lot of data actually going out through APIs on
And
if you can't find this data set, you maybe will find an API to get your
access and
So the question that I would ask is really, what am I interested in? Rather than what is there, where do I find the data? Because when I want to learn something, I get bored very easily, it's just me. So I'm gonna pick something that I'm interested in and then go find data sets so that I can mess around with the data. And but I find that I'm much more inquisitive if I've got something if I got data about something I like. Read anything. But that's how I find all sorts of interesting data. Cause it's
Google. Google is your friend in every data way possible. If you have a bug, Google, Stack Overflow. If you want to find data, Google that. One thing that I tell students often is, often our first instinct is to ask a question because somebody knows the answer, but it's actually a lot better for you and a lot better to learn if you go find that answer yourself, because you'll fail probably 5 times and then you'll realize what doesn't work for the particular problem that you're trying to do. And then the more and more you do this, the less you have to Google. And you know it a lot better if you try to first answer the questions yourself, and of course ask if I'm working for hours and can't find the answer. But I do recommend that, really trying to dig in and find information. There was a question online, and I'm gonna it was about data science in particular, but I think it will apply to everybody. The question was, how did you get into data science? And we can probably each talk about that. I have a really different way that I got into data science. So I have a master's in public health, as I said, which I had a specialization in health policy analysis, which is a lot of econometrics, which basically is designed you're trying to measure policy effects. There are thousands, millions of confounding variables or things that affect that model and how we would measure how the policy was working. So it's a very different thing than I do now. It's different type of modeling, but it all has the same base. But healthcare wasn't for me. It's particularly policy I found was somewhat frustrating because a lot of people already have their mind made up. So that was not what I wanted to do, and I went into the data science field from there. Bayer Cropscience gave me a chance. I was a contractor. So if you're looking to get into it, I recommend, if you don't have a lot of experience, I had a great relationship with my contract company. And it's less risk for them, so then you are able to go in and get some experience, and then maybe your next job isn't a contract job. But my contract, first one was 6 months, it was extended again, 6 more months, and then it was extended for a year. So contract doesn't always mean short term either. So that's something that I do definitely recommend. But when I was in that, I had to put a lot of extra work into outside of work to try to figure out what I was doing, because I wasn't in order to get projects when they needed the results, I had to work harder to know how to use R or know how to use the tools. So that's how I got into it, and then I moved to Whole Foods, a full-time job after my contract opportunity. So it helped me get exactly where I want, and it was the right place for me.
How many data scientists does Whole Foods?
So that's somewhat of a difficult question because marketing has their own data analyst, for instance, a competitive intelligence is their own data analyst, and then there's a data science team. So we all do similar things, but I think the data science team is more in the advanced modeling space. So how many, we just hired 2 people. I'm not gonna count, but 9 or 10 people.
How do you define data scientist?
Yes.
That's because all themselves data scientists.
So I get asked that question a lot. What's the difference between data analytics and data science? And that's part of the reason why I wanted to do this. So there's a lot you can do with more basic descriptive statistics with Tableau, data visualization, of things that are more, I would say, they don't have that advanced statistical modeling piece in there. I think that that is the differentiator, that and big data work bit on the cloud possibly. When you look at a data analyst position, it's more the Tableau, the Alteryx, data munging, data cleaning, trying to build business insights from those data. Whereas I think in the data science field, it's more predictive analytics. You're trying to predict what's going to happen. Less reporting. I do less. I've had data analyst jobs and data science jobs. I do less data munging and just trying to do those basic statistics. Whereas now I do more modeling. So I would say that those, because I've had both. I've done both. I was a statistical data analyst and I was a data scientist. So that's kind of how I see the difference.
The fine line is data scientists are proactive. Every other data X job is reactive. Data analysts talk about data scientists are very much looking to the future and trying to say what's going to happen so you can change your strategy.
That's a great way to look at it as well.
So do you have this sort of questions? Would somebody in your business come to you and say, you look at our data and try to predict which employees are going to leave, which item we're going to run in stock, try to solve, or do you look around and try to solve your own? Just look at the data and say, what can I do with this data?
So the question was, do stakeholders come to you with ideas on projects that they want to know or insights that they want to find? So the answer to that is yes. So I at Bayer was really involved with stakeholders, so I can speak more from that perspective. So they would come to us, they have an experiment, for instance, that they want to run, and how much data do we need? So they'll come to us, and I got asked all over and over and over again, how much data do we need? And I then, when they say that, I'm like, okay, in order to answer that question, I need X, Y, and Z. Without that information, we cannot do it. So in this case, how much data do we need? Do we have historical data that looks similar to the thing that you're trying to measure, so we can make an estimate there? How do you want to analyze the experiment? What structure do you want? And then they might not know the answer to that question. So they say, I want to find X, Y, and Z about what's the relationship between these two variables. Okay, and then I would go to them and say, okay, so this is what you want to know. I would give two factors and would say also, given my experience, you might want to control for these variables and go through. So the best thing that I found, they'll come to you with data usually, and at Bayer they did. They would come to me with data, they'd come to me with a question. And then the first thing I would do is to try to understand the data, visualize it, try to look for discrepancies or errors, and then I would come to a meeting with 20 questions on, because they knew in that general, the stakeholders know the data better than we do, because they have their hands in it. They're usually one planting or cleaning that data. So my job was kind of to connect the two, to give the statistical expertise that they didn't have, whereas they had the data piece that they understood what their data was telling and what problems there are with it that we would.
You mentioned early on some of the programs that you work in. Industry-wise, there are specific programs program language that you find is, dominant in the industry?
The question was, is there a programming language or a tool that is dominant, in the field? So I can speak to data science. When you look at data science jobs, they almost always want SQL because most companies have their data in databases and you gotta be able to get it. And then the other two programming language wise are, right, it's either R and Python or R or Python. I would say R is like statisticians and advanced statistical analysis. R is good for that. And Python's better for machine learning and just programming heavy jobs. I would say Python is growing the most. I've seen the graphs, and I would say that it is the tool that if you were going to learn one, you probably want to learn Python. That's my advice. But it's going to look different for data science versus what they do.
Yeah, and I would say, Python, being it is growing so rapidly, we're just start with Python. Because, I learned R in college, now learning Python, there's a lot of similarities. So when you learn one, you're gonna pick up the other. But, when you look at data in general, every data job, a bonus requirement for them is looking at Python, because Python. Because Python can be used across any data job.
Multi-platform.
Yeah, multi-platform, can be embedded in pretty much anything.
Automated.
Python scripts can be automated into AWS, so it can do ETL. Pretty much anything.
It's the glue between just about anything.
Yeah.
Are there specific Python modules or class libraries?
Python, I'm actually learning it now. I'm a beginner, but pandas and NumPy are just those are the ones that you would want to start with. Probably starting with pandas, I would say. Most of the stuff I've done has been that. But the question was packages and modules in R and Python. Go ahead.
I'm actually in a data boot camp right now, and 80% of it was Python.
So the interesting thing about Python, to talk from a language perspective, because that's kind of what you were asking. Python can be a scripting language, it can be an object-oriented language, and it can be a procedural language. It's a bit of a chimera in that the functionality of the code base, it keeps getting extended by the user community. It's similar in nature to Perl. You use any Perl. They used to say that Perl was the glue that ran the internet. Python's kind of now the data glue. Still hasn't overtaken SQL, but SQL only works with a relational database. Python will work with any kind of unstructured data or structured data.
From what I understand, Python also, they're writing a lot of libraries for Python special purposes. So if you've got a question, you can find it out.
Cloud services, Python.
Yeah, I mean, there's some other things out there, but they're more niche. Scala and Kafka. These are not central to what you see. There's some Spark things as well, but Spark's not really language. Python will run Spark, but Java runs better. Spark, it's frustrating. But those are not really core or central right now.
Yeah. So one question I get asked, like, why would you use one over the other? And feel like in my current, like, trying to learn Python, I've got a pretty good grasp of that. So for anything that has unstructured anything, Python is much better. So if you're web scraping using JSON, anything of that sort, Python is better. If you need something to work fast, Python is better. So data visualization in R, I think, is superior to Python in a lot of ways, ggplot. So much so that Python put a package that can run ggplot inside of Python because I think people were moving to R for that reason. The other thing, so I told you I was working with that data set that looked at admissions to substance abuse programs. There's a ton of missing data in that data set. And more so, some of them have complete, some of them have a lot of missing data. So I was looking, because I'm used to R, I'm like, okay, how many multiple, I was trying to find a way to do multiple imputation, which is basically filling in that missing data based on the data that isn't missing. Because most of the time things aren't missing at random, they're missing for certain reasons, so I was looking for imputation, like ways to do that in Python. I could only find one or two ways to do that, whereas in R, there are a lot of really established multiple imputation packages that do very different things in different ways. So what is distinguishing there kind of on the back end is the advanced statistical modeling. So maybe like a time series model or a Bayesian model, you might be more likely to use R, and machine learning is far superior in Python. I was trying to train this model in a machine learning model. It died and errored out for memory problems in 30 seconds in R, and it ran, I'd say, in 5 to 10 minutes in Python, no errors. So that's another example.
R doesn't compile Python files. It's a big difference.
So for any of you who in your role, you do like ETL on your day-to-day basis, what does that look like for someone who doesn't like maybe do that on a day-to-day in their role and they're trying to show an employer that they're capable of doing that? Like what projects or resources would you recommend?
The question was for people who do ETL in their job, what resources do you recommend in order to learn more about that? What does your day-to-day look like with using ETL? And I will divert that one because
Whatever first you want me to, I'll do ETL.
Yeah, we're gonna, why don't you go first and then I'll start talking about some.
Sure.
Yeah.
So, I actually just went through hiring somebody too. But one of the first things is, that's kind of the base, because you have to pull it from something in order to start the ETL. And, like they were both saying, all relational database right now. So SQL is where you need to go. Secondly, not many people use Alteryx, but that's kind of our main tool for ETL for analytics. Definitely don't recommend that because it's hard to scale. But when you are doing analytics, it is definitely that quick and dirty ETL. Use Alteryx. The other things that we look for are Python. Python does ETL very, very well. Taking data from one place, doing something to it, and putting it.
The example that you gave earlier, created an interface at the example of that for you.
Yeah, essentially it's doing the ETL underneath. So it's creating a query that pulls the data out. It's not transforming it, but then they get to choose.
So my perspective on it is more, say academic or theoretical, but when I hire somebody, here's the first question that I ask: tell me the difference between a relational OLTP model and a relational OLAP model. What's the difference? Can you describe what a star schema is? Things like that. What's a primary key? What's a foreign key? What's important? What is a fact table? What's in a fact table? What's a dimension table? What's in a dimension? Well, things like this. What's the difference between an attribute and a metric? Okay? So understanding this and these relationships, that if you want to know about these things, great reference. This guy's name is Rob Kimball. There's another dude, Bill Inman, but he's kind of fallen out. So we were talking about the Puerto Rico situation. Today, I built an ETL process that created a surrogate key, which is a foreign key on all the invoice transactions back to 2016 in the data warehouse, and did that through a series of really joins in another Oracle toolset called Oracle Data Integrator, which is similar to Informatica, which is more enterprise IT class product than Alteryx. So highly technical, but I translated the code that I had written in SQL into Oracle Data Integrator so that I could schedule it and so that it could run. And I ran that code today probably 4 times, and we'll integrate that into what we call a load plan, which is an incremental process that loads on a nightly basis the entire warehouse, extracting from all these different sources. Talk about the ERP, we have another CRM system, which is primarily for sales service, and commingling that information and curating it. So my take on it is more, okay, do I have orphan rows, right? I want to make sure that the data is clean and that it matches the source system, which it isn't the perspective that you get from Alteryx, right? Alteryx is good, fast, and produce results that are consumable versus lay a whole bunch of things together and make sure that the relationships are there and that the support for an enterprise class solution will take the blocking and tackling, or the heavy lifting, the blocking and tackling off the business users and also the data scientists. So they can spend, the business users can spend their time conducting business, and the data scientists can spend their time whatever black magic arts they're doing with you telling us what's going to happen in the future. Does that help?
Yes, thank you, and thank you for the resources too.
Yeah. There's a lot of stuff out there. There's the Data Warehouse Institute, all kinds of ETL or ELT. Not a real big believer in ELT. I can talk to you all about it.
There are times when
The Oracle Data Integrator is the ELT tool, and the real difference is that you don't have to stage the data anywhere. You don't need an actual additional server. You can move it from relational database to relational database without having more hardware, more computer storage, and more network bandwidth. Make a lot of sense to ship ones and zeros and transform it in another place when you can all natively in the data.
I think what I was thinking about was more just dumping data as fast as you can get it in there. And then where you pull it out is where you do.
So maybe a follow-up if it's all right. So you mentioned SQL being kind of like the basis of everything. Where would you bolster your SQL skills if you don't work in it on a day-to-day basis? Like maybe what online tool place would you go?
Question is, how do you bolster your SQL skills? Ask this guy, because I would have to have a problem with, like, oh my gosh, I know how to do this problem, help me figure out how to do it. So, and just, so he is the best one to answer this question.
Yeah, I mean, so what do I do? There are some code challenges and places that you can go to, and you can see different solutions of these arcane problems and the way that people address them. What I normally do, and I do this quite a bit because there's something sticking, is I'll go back and write code and then think about it for days, and then go back and refactor it and see what runs faster. And I literally wrote a series of joins dealing with this code, which in the country ISO and the state. I wrote this join 4 different ways, and I ran what's called an explain fan on each of them. It will tell you how fast this is going on. They all suck, by the way. But because I know the way that databases think and sick and twisted, the best optimization was reversing the order of the field references to the tables in the join criteria. So table B first is faster than table A first.
And for someone who's, oh, go ahead.
Oh, twice.
I've seen that happen before, with a very large table. I forget the exact structure, but depending on where I joined to the parent page. One was just extremely fast, the other one basically never.
The challenge in the case that I was dealing with was we had again, I was creating a circuit key. The natural key, which is think about state and country, 2 separate fields. And in order to join, I had to concatenate those 2 fields together because of the way that the data was, that the data existed. And that concatenation is heinously expensive. The database goes, I cannot use an index to deal with this. And there are some ways to use hashes. But if I put the field that let's say a single field that can contain the what's called the integration ID, which is essentially the primary key of it was able to seek on that and then push the concatenation into a temp area memory. And in there. Sorry. That's I mean, I did it 4 different ways because I didn't like how slow it was.
You're looking for SQL in not a deep of knowledge. And you're just looking to do some of the beginner stuff. W3 Schools. It gives you basics.
Yeah, I've run through their testing. What would you recommend as a step following that?
Coursera.
Okay.
Something on Coursera where you can get like a certification.
GutsyHackerRank.com has SQL challenges. Okay. Where they don't really tell you how to code the SQL, they just give you a problem to solve.
Yeah.
And it's just SQL.
The second job that I had when I learned database, the second job that I used SQL, the dude gave me the job. And then he gave me a book, this T-SQL in 21 days. T-SQL is Transact SQL, it's Microsoft and also Sybase. What that is. Read that book, and that book taught me almost everything that store procedures, which is beyond just the regular structure query language. Allow you to create packages. I mean, it's still a good book. We don't really use books that much anymore, but
I do.
Thank you.
Yeah, I am not an auditory learner at all. So I very heavily use books. But the biggest piece of advice I would do with SQL with anything, until you do it, you have no idea what you're doing. So you can take an R class, you can take a SQL class. Until you actually try to code it and solve the problems that you're gonna have when you code it, you don't know what you're doing. I took an R class going into my Bayer job. I came in on my second day, I'm like, crap, I don't know what I'm doing. Okay, I gotta learn and figure out how to code in R, and I did. But you have to face real problems. So
I think one of the things you learn by actually doing the coding is in certain situations.
the comment was that you get like context of what works in certain situations. One of the biggest surprises for me when I started programming is how much we guess. So when I don't know what I'm doing, a lot of times I'll Google it, yes, but their problem's going to be slightly different than mine in almost every case. So I will take 10 guesses at something, and usually one of them will work because Python and R, once you get better at it, they're somewhat intuitive in that you know what to try. I say throwing something against the wall and see all day. So, and that can be frustrating to some people, and those are the people that probably won't need in like a data related programming field. If you can't be frustrated by a problem and keep working on it, then this is for you. But if you find that to be puzzle that is fun to solve, then this career is going to be for you. But I do recommend using those open source data, just thinking of a question that you're interested in, whether it's baseball or opioids or the environment. Say, I want to know X. Go try to find it and solve it. And I'm learning Python by writing machine learning code for that opioid data set, just because I knew I needed to find something to try it with, or I wouldn't know what I was doing.
yeah, whenever I want to add a tool to my equipment, one functionality, want to do something different, I'll just make myself write the code in a different way. Like, so here's an interesting example. I keep going back and forth with Kelsey on regular. So the normal way that we would parse, SQL isn't really good at parsing. You can substring things just fine, right? And that's like, you can nest 50, I can't tell you how many nested substring functions I've seen, right? Like inside. Like, I just figured out one day, you know what? These enterprise class databases have regular expressions built into them. So now I just made myself write regex, unless the substring is very simple. So I'm not going to regex for the country ISO, because it's two positions. But I started putting regular expressions in everything, just to see what would happen.
Regular expression is when you have, I'll give you an example, it's easiest to understand. So at Bayer, I worked with genetic codes that told us how our products were built. So every piece of corn had a genetic code. Well, genetic code. So they had different parts in them. So there were 3 sections of that genetic code, and we usually had to separate them. But just like everything, some of them had a standard way of being separated, some of them had non-standard ways of being separated. So they were letters and numbers, and I had to find the patterns to pull out the information by looking at where letters and numbers are and what positions those were in, and then find that code to then basically that information out, which is the reason he brought it up. Is I hate regular expression, and he loves regular expression, but genetic codes were not something that I enjoyed.
An example of regular expression within MySpace, bringing out an address. You need the street address, you need the street name, city, the date, that it's all separated. Street names could be words or, and regex really.
But you have to have a familiarity with it. You would forget what the operators are.
Yes, there's a lot of operators.
Like a different language. Like a different language.
It is, honestly, yes, but it's very similar across platforms. The regular expression is gonna look very similar in SQL versus. So that is one good thing.
Sort of dialect.
Yes, and yeah, you can write the same thing in several different ways, exactly. So, I was a big string R, so. Flyer and string R, but I haven't done anything in Python.
Yeah, if you want to match a pattern, any sort of pattern, use regular expression. And you can even take hex code from a photograph, right? and look at the hex code and pull patterns out of it. It's extremely powerful. But I have to make myself use it.
Somewhat frustrating. I think that's why I have a love-hate relationship, mostly hate with that.
You haven't found it yet, regexpal.com is pretty awesome.
I have not used that yet.
So you can put like a sample of what you're searching for in the bottom, and then start typing regex in the top, and it will highlight it if it's finding what you want.
That's like.
regexpal.com. Maybe it's regexbuddy.com. There are a couple websites that do
Yeah,
that.
there's another one.
But you can put sample text in that body and
And notice that the regular expressions didn't come up right at the beginning, but now we start talking about it, and everybody's like, oh yeah, regular expressions, right?
Yeah. Are there any other questions that you guys can think of? Okay.
So, as y'all being in three kind of separate spots in the data world, what are the different types of interview situations be like, if I'm interviewing with you, what does that look like?
So for data science, it very much depends on the company. So I interviewed with Facebook at one point when I was looking for the job that I have now. And the first one, phone screen's always the same. They'll ask you what you can do, get an idea of your skills, and then if they think that you're somewhat qualified, they might send you on the next round. But Facebook then puts you on like a white screen, and you're on a webcam, and they say, code this. You have this data set and code it now. And in this case, it was with the flyer and R. So they were very simple things like filtering and summarizing the data, finding out how many rows are in certain groups. The actual problem that they had me trying to solve was having to do with flagged posts that are flagged as inappropriate. So they had me finding some summary statistics based on that. And then the next part was an analytical portion where they asked me, the really hard question that they asked was, okay, so we started this model, we're using this model, it's successful in finding these flagged posts. But now, like, the posts that where the flags are removed are getting less views. So explain that. So, and that is one, so those are gonna be like the Google, the Facebook, IBM does that, I think. And the big tech companies, for the most part, do that kind of interview. At Whole Foods and at a lot of other companies that I've interviewed with, it's more of, like, you sit in a panel of people who all have a lot of experience, and they'll ask you, at Whole Foods, it was very analytical questions. So if you had X scenario, what would you do to solve this? And And then it all, no matter where you go, it's gonna be the same standard questions. What's a difficult situation that you've been in that you handled well? So those kind of questions are always gonna be asked. So on the data science side, it's gonna be both. But you might not have the coding interview.
On my side, similar to what she's talking about, it's very company dependent. All depends. I was at Walmart, I was interviewed before, I had to take a, I told them I had to start something. Then on the other side, like at Whole Foods, it is still panel driven, more of a conversation. We've had people that pick our system, they put, white on the, put flag VHR system, go up on a, trying to identify in the interview is if you know what you say is on your, or on your resume.
Yeah,
So it could range from questions of
Yeah.
analytical to very, very specific detail. You put something on your resume and I want to drill into it until I figure out what you actually did. Or were you partnering with somebody else?
Whole Foods did more of that than I've ever seen. Like, so they picked a very specific part of my specific project that I put on my resume, and then asked me a specific question about what method I used in order to find those results. So I've never seen anything quite as specific as Whole Foods. Like, I could tell when I came in the room that they had read my resume, whereas in a lot of companies, I think that they kind of read it while you're talking to them. They're talking to you. So that was the Whole Foods, I think that it's unique for sure. But the recruiters have always told me, if it's a coding language, if you cannot code in a coding interview, you probably shouldn't put it on. If you cannot answer very specific, detailed questions about an analytic model, don't put it on. They will catch you. That's designed to try to see if you're lying.
And one time.
So, out of the three of us, I can guarantee you that I've had probably interviews.
Yes.
Yeah.
Yeah.
Yeah. So, I'll give you some different perspectives on it. Like that. So, when I'm interviewing, usually a series, probably at least 3 and maybe 4 interviews. So the first one is just a pre-screen, somebody who's just know anything about technology at all, wants to make sure that I can get on the phone with them when I get on. And it's always a phone screen, never in person. The next one will be a phone screen with the hiring manager. And that's generally, okay, am I not an idiot? I have some technical prowess thing. Am I worth talking to and getting to the next? That next level is usually either one or two, be a technical interview. And that can either be in person or via Skype, where the team that I would be working with will say, okay, how do you code this? How do you address this? What are the techniques that you use? Try to get into some very specific technical pieces. Make sure that I'm not making things up. The last interview, it is usually what I would call, and this is kind of a newer thing, a team fit. So it will usually be on site, and is there, do they get a warm and fuzzy with you? Do you get a warm and fuzzy with them? Like, okay, kind of kick the tires a little bit. And after that is usually not really part of the interview process, but then you start talking numbers and compensation. Because the comp piece of it really, as long as it's in the ballpark and you get through the comp conversation is really just subsequent to all the other steps, right? It's all gonna work out and we can. Here's some things you didn't ask that I'm gonna tell you guys. So from a comp perspective, there are a lot of ways to get money from companies that aren't, it's not just about, salary. So if you're getting a job in town, and you don't have to reload, there will usually be reload money associated with that job, which can turn into a signing bonus. If you don't have. So signing bonus is important. One of the other things that I always ask for is equity, because you're not gonna get it if you ask, right? So, I also talk about, the flexible comp around bonuses and what does the bonus structure look like, and the history of say, the department bonusing or how it's actually calculated. Way I'm not gonna say leverage, but ask questions so that you can get compensated. On the other side of it, like when I interview somebody, I told you I start with the theoretical first. Okay, can you tell me about data modeling? And then I break down depending on who I'm interviewing for, what position I'm interviewing the candidate for. I'll ask them to rate themselves on a scale. Yeah.
Yeah.
I ask them to rate themselves on a scale, and it serves two purposes, right? Can you follow the instructions that I'm giving you? And you'd be surprised, and I am not surprised anymore. You know, how many people do not follow the simple scale 1 to 5? What do you mean? I don't know. Simple, rate yourself. Then I follow up with technical questions to see, okay, what you told me your skill level was. Do you really have that skill level? Okay? And so it's sort of a trust but verify thing. Russian proverb that won't break the soul, right? Trust but verify. You guys didn't tell me this? Okay. Then actually do it. I also read resumes, and I've seen enough resumes to know where I see bullet points copied from resume to resume, and they are the same. And so don't do that. Yeah. Yeah, and it's pervasive.
The trick for them.
APS.
The trick for screening is how do you get it? What it usually comes to.
But do they get the interview?
Not with me, they don't.
Yeah, I was gonna say, sometimes, well, there's two approaches to that. No, they shouldn't. Sometimes it's just fun to talk to them. They're not gonna move beyond, but sometimes it's just fun to talk to them. Which is really good. To his point around the rating though, be honest. Don't say you're a 9 or a 10 if they're having you rate out of 10 and you've been working with it. Be honest, say you're at 2 to 3, but you're and be very specific with what you're working with. Tends to work better than trying to say you're an expert.
And then the other advice I would give, get on the company's website and read about it, because they're gonna ask you why you wanna work there, and they're gonna try to find and see if you've done your homework. So, get on and learn a little bit about the company. It takes 10 minutes to come on and come with questions. Every time they're gonna say, what questions do you have for us? If you don't have anything, then you're not gonna look at there either. So, on the phone, there was a question about this, there's a shortage of data scientists, but everything asks for 3 to 5 years of experience. that is not a data science problem, that's a job problem. So until you do a job, you don't know the job, and people want experience because then they will be able to do the work without having to be taught the whole way. So people always want experience because then it helps them and they don't have to do so much teaching on the job. There are ways around it. Like I said, I was a contractor first. I think that's one of them. In some cities, not in Austin, mostly in places that need tech workers, there's something called launch code. It's in St. Louis, I think there's one in Florida, other places where you take an aptitude test and you have to know a little bit of programming in one language. And if you pass that, they pull you in for a night class all for free. Pull you into a night class and it's similar to a coding boot camp, but it doesn't cost anything. And then they will place you in a large company. Bayer did it, Centene, companies like that for like a 6 or 8 month trial. And then if you do well there, like 75% of them get hired full time. So there are ways around that, and I think Kaggle is a good one because I've heard of people getting jobs through learning on Kaggle because you're competing with the best. So, but wanting experience isn't a data science problem. It's just how the job market works.
Yeah, kind of to that question, it's kind of funny. I've seen some job description was asking for 7 years experience. Language has only been around for 3.
I saw a job posted earlier today about Spark. It's only been around since 2014. They wanted 6 years experience.
Yeah, so sometimes it's they ask for that experience because it'd be nice to have, but you can sometimes get around that. So just when they ask for experience, somebody may have put that job description together that isn't quite fully aware of. Spark. Spark is only been around.
Actually, I'm a software developer, not a.
And then I think it's pretty rare. I know some companies do they have screening questions on there, and it's like, do you have 4 years of experience in X language? If you put that you have 3, you're not gonna. Nobody's gonna see your resume. It's an automated no. But that's pretty rare. I've seen it here and there, but for the most part, somebody's gonna look at it holistically. If you get flagged, I don't know much about that but they'll look at it holistically and see if you might be a good fit, whether it requires 5 and you have 4 or 3. I've gotten second interviews on things that I definitely didn't have years required that I have on there. But if they're asking for 10 years of experience and you have 3, don't want it. That's my other piece of advice.
I think the most confusing thing I've seen out in the market is that a lot of the different functions can be related to analytics or convergent. So it depends on what viewpoint someone has descriptions written up. You have to read it carefully because, like I was saying earlier, there are about 4 or 5 different skills that are being.
So you'll see full stack data scientist, which is kind of it's a combination of us, and they're looking for a purple unicorn, in my opinion. You're not going to find many people who have the really software engineering and the data science. There are people who do that, but not that many.
I would say that those aren't roles. And I say that is based on my experience. There's not a concept or understanding at the decision maker what is required.
They've been overworking too.
Yeah, I mean, we're looking for. started taking. So we ended up deciding that it was. Did have that requirement. But we just found went out. Did a little bit better. Go-getter type person. Are you gonna learn it quick?
My boss at Bayer, it was my first data science job, she said over and over and over again, you're never gonna find someone who has all the skills that you want. Particularly in agriculture. I mean, so she said, you wanna find somebody who, likes to learn and who will learn fast. So curious and quickly will learn. That goes right there. And she said that not once, but many, many, many times.
So one of the other things too, here, you actually, after the fact, get a job and you don't ask them if they get a trial. Sorry. We were able to get an alternate license for starting for about, they're able to get her one. Don't have that. Get there before you.
Any other questions?
Just wondering if, just a little more understanding of exactly what is consultant or
Yeah, I have my own consulting firm. I have so it's been a long time. And again, like I said, I primarily focus on the product that started out like as a meta search engine, put a front end on, and it's now called Cloud. So Oracle Analytics Cloud has been through multiple iterations. I do these applications and have all over the world actually. And I've got all this like we're trying to port them in on-prem. Talk more about.
and just was, you know, for a lot of people, so it's been business.
Yeah, one of the trends that you heard us say cloud quite a bit. Because very very common. One of the things that you're not hearing, which is something that I am actually DevOps. Yeah. So this DevOps, what it means to me, ability to ship code, to ship product quickly, and the continuous release. That is very. There's a lot of business value there. Things that you talk to where they like you need to be able to fail fast, and you need to be able to recover from it. That's why and the hell job be able to do that. The Oracle ecosystem is it. So built on essentially this mainframe technology. Now, what you got, especially in the cloud, is this not just a virtual machine, but a container. And this idea of container is deployable almost anywhere. It's a stateless machine. Personally, databases don't like stateless. That's a whole other discussion. But if you want to get into this field, what you want to look at is an open source technology stack, and something that will allow you to get into this value add.
Saw an article this week talking about which some company out there.
Well, the best way to think about it is two use cases, right? Not everybody has a Tesla, but just about everybody's gonna have one. They push releases of iOS, and things break because they always do when they push it. They're able to correct those features almost immediately because they're set up to do that. The release cycle that you would think about with enterprise class software, everybody would be able to bug fix so quickly. And it's the same thing for Tesla. It's some updates push the OS to the cloud.
Kind of piggybacking off of that, one thing that is sort of programming related, but that a lot of companies get GitHub.
Yeah.
Version control going off of that. So, when you produce 5, 10 different versions of code, you need to still have that old code, because sometimes we'll try something and it won't work, and then we'll go back to the old way. So, I recommend learning how to use Git and Git well. Also, if you create one of your own, then that looks good to employees. Okay, yeah, could you, yeah, so like I said, I teach a class through the library here. Maybe it's my computer that is thinking. Must be, because I always have trouble with this versus, right? Yep.
Just tell me what you do.
Yeah. Yeah, so I'm just gonna go show my website. Wait, it's not working with yours either. Yep, something happened.
Turning it off and turning it back on.
We'll see. It almost never works when I come in. Today was an exception, and apparently.
So not your computer.
Not my computer.
Not your computer, it looks like.
Yep, this thing I think is very.
I plugged it in earlier and it was just.
Yeah. So, which is why I really wish I would have brought my business cards. So, do we have a whiteboard? Yes.
We do.
So, okay. Hopefully the marker is not going old school.
I love it.
All right. So my website, which has all my class information on it, is my first and last name. .com. So, what it has on here, I do Saturday for the most part classes. Some of them are webinars and some of them are in person here at this library.
When's the next class, Kelsey?
So the next one I believe is the third week in January. I think I might have a webinar the week before that. I could show you the schedule, but it's not on here, but I will read some of the topics off. So one thing that I try to do, and I'm going to do with this eventually, is I put all of my classes online. The videos are on there. I also try to break them into subjects so that if you already know how to find the mean, median, and mode, you don't have to sit through 20 minutes of that if you already have an understanding of it.
Although you should.
What he said. But so one thing I have always been a little frustrated with is Coursera. In order to get your end certificate, I have to go through linear regression. Again, I don't want to do that. So I'm trying to put that on there so you can go where you need to go. It also, on this every page, it has the video and then it has the slides below it. And then it has a link to code where you can see, I go over code in class. You can run that while I'm doing it. And you can, there in some cases for the programming classes, I try to get practice code. So that is there as well. All of that is on my website. Under all the stuff that's already happened is under the tutorials tab on my website. The schedule will be under data science classes. I have done pretty much almost all of an introductory twice. I've done an intermediate once with the exception of looping we haven't gotten to yet. And I've done most of a like basic statistics class. We're on linear regression right now. So I am moving on to the more complex programming and the complex statistical models, which is kind of was the idea to eventually get there. But you can always go back and listen to those same courses if you have missed them. So I believe the first one might be a webinar. So I have our programming webinars on here. And so the next class, I believe if the next our programming webinar is looping. So that will be on December 7th from 10:30 a.m. to 12:30 p.m. So that's
That was already, that happened. We did that already. January 20th.
Sorry, January 20th. I said the looping on January 20th. It's my webinars are all pretty much always 10:30 to 12:30, except for ggplot, which usually gets allotted more time. Just because it's more difficult. I have also on here data cleaning and debugging. So that's going to be a programming topic. Later down the line in April, we're going to do interactive graphing with RShiny. RShiny is basically a tool where you can create this code and then users without any software, it's hosted on a cloud platform. You go in and they look at drop-down menus, select certain attributes, and then the graphing will change. You can actually build models with this as well to spit out results based on user input. So that is the R programming side. We're going to get more into statistics. So today was the careers and data panel. So the next one we're going to have, we have like a part 2 of simple linear and logistic regression. So I did a lot of how to build them, but I didn't go into how to evaluate them because it takes a while. And then there is a next one on multiple and multinomial logistic regression. So multiple regression, so more than one variables. Then the next one would be an end-to-end data science project. So the one that I've been talking about, the opioid data set that I'm using to create machine learning models, I'm going to go through it. And hopefully we'll have actually an RShiny app and everything to back it up. So another thing that I'm going to try to do is a data project poster session. I'm actually working with several meetup groups to try to get this on their groups as well. The idea is you have any project that you want to do in any programming language, it just has to be data related in some way. That you can go, you create this poster, you have to put in an abstract just so I know everything's appropriate. And then you would come in and have that poster, and employers would come and ask you questions about it. And so it would give you and them exposure, and also show that you can make a product. Then we would be going into more of the machine learning side. So data preparation, and I'm going to start with k-nearest neighbors because it tends to be the most intuitive one. And then Michael inspired this. So when he was asking me questions, a lot of them were like, what model do I use for this specific problem? And so the hardest part of statistics is choosing the tool that fits the data. So I'm actually going to have a class on it. Like, okay, when do you use machine learning? When do you use a linear model? When do you use a t-test? Kind of like, so I'll give different examples, and hopefully that one can be more of an interactive where we can ask questions.
I feel like the end of it's gonna be, you have to run all the models and then see which one fits the best.
No.
And that's the one you're using.
No, that is exactly what you don't want to do. That is wrong. So no, I will show you how to do it the right way. So if you go back to my videos, null and alternative hypothesis is what you would want to review. So, and then we'll go into decision trees, random forest, and gradient boosted trees. I'm going to start like going faster is the idea. And so I'll give you a high level understanding. And then if you want to dig in, you can go dig up the details. And then something really cool that I used recently was the profit package. So Facebook created this time series for dummies, basically package. So they have in their documentation that they have to do all this time series forecasting, and nobody has enough knowledge to do it correctly. So they then tasked somebody who was an expert in time series to go create a package that worked for most problems pretty well without a lot of tuning involved in it. So it was like the idiot's guide to time series. And it also allows you to account for events. So if your data has weekly seasonality, yearly, monthly seasonality, you can actually put holidays in there that's already built in. So it's a really cool tool that I thought was extremely interesting when I used it. So that's what's planned so far. And it's all on my website. There, data science classes will take you, and then it's split into statistics and R programming. So, are there any other questions? All right, on your way out, feel free to take some coffee mugs, and there are our studio stickers there as well.
Thank you for doing this.
You're welcome. Thank you, I appreciate that.